Hi everybody and welcome to another Bowtie Teacher video. This is a follow-up to the paper 1HR where I changed all of the numbers in the paper to give you another crack at it because, as you know, we don't have much to work with. So hopefully you can go through this paper a second time with different numbers, and that will allow you to try and practice the questions to see which areas that you're struggling with and which ones you need to work on to improve. So let's get to it. So as we go through to question 1, you can see that I've tried to change these so that they're slightly different in each question. If you take a look here and in the description below, there'll be links to my website where you can download these papers, print them out and do them first, and then you can try and refer to these questions and see if you got them right. So for question 1, we have an inequality here, and we would have x is greater than or equal to -1. For the inequality, we would subtract y from both sides and subtract 7 from both sides. So we'd get 2y is greater than or equal to -10, y is greater than or equal to -5. Question 2 is a show that question with fractions, so we're going to make them top heavy. 3 times 3 plus 2 is 11/3. And then we're going to do 4 times 1 plus 3 is 7/4. Cross multiply 44 and then multiply the denominators. And then we're going to 3 times 7/12. And that would give us 44 minus 21 is 23/12. And that would be equal to 12 into 23 go 1 and remainder 11/12 like that. Table of values, -1 plus 6x minus x squared. So we could use our table function for this, menu number 9, and we have -1 plus 6x minus x squared. And we want that to go from -1 to 6 and going up in ones, so step up in ones. So -1 is -8, then 0 is -1, 1 is 4, then we've got 7 for 2, 3 is 8, that's correct, 4 is 7 again, oops, 7, and 5 is 4, and then 6 is -1. So for these ones in red here, you might want to put some working in, like for the 4, for example, -1 plus 6 lots of 4 minus 4 squared, so that you can get that 7 there. On the grid, draw the graph from 0 to 6. So 0, -1, then 1 is 4, 2 is 7, 3 is 8, 4 is 7, so it's symmetrical around here. 5 is 4 and 6 is -1. So you would try and draw this with a smooth curve. Not easy to do on the computer, but you would try and make similar triangles. So we look for a side that is common to both, and then we divide them to get the scale factor. So 24/16 is that's going to be 6/4, which equals 3/2. So the scale factor is 3/2 or 1.5. So 12 times 3/2 is 18 centimeters. The area of triangle is 325 centimeters squared. Convert that area into meters squared. So we're not actually doing anything with the area scale factors here, we're just turning them into meters squared. So imagine I have an area of 32.5 and 10 centimeters. You can choose any numbers that will give you 325. And then what you can do is that you can convert both of these into meters. So 32.5 centimeters would be divided by 100, and we have 0.325 meters. And 10 centimeters, when you divide by 100, that will give you 0.1 meters. So now we can do 0.325 times 0.1, and that will give us 0.0325 meters squared. Factorize this thing here, so we're looking for two numbers that multiply to give 36 and then subtract to give 9. So we're going to have an x here and an x here, and 12 and 3 will work. So we have negative 12 and plus 3. Some probabilities here, we have to find the missing one, so we're going to do 0.21 plus 0.31 plus 0.06. So that gives us 52, 58, 0.58. 1 minus that to give me the missing one is 0.42. So now work out the probability that Julius takes strawberry or mint. So strawberry or mint is those two added together, which is 0.73. Football team played 96 games. The ratio is 5 to 4 to 3, so we're going to do 96 divided by 5 plus 4 plus 3. So that's 96 over 12 is 8. Now that we've divided by 8, we can work out these ratios. So we've got 5 times 8, 4 times 8, and 3 times 8. So we have 40 to 32 to 24. Let's just check that adds up to 96, 40, 70, 96. So the ones that they won compared to the ones that they lost, we subtract those and we have 16 there. Two numbers, A and B, find the highest common factor of A and B. So if we imagine that the Venn diagram is like this, then we've got 3 cubed and 3 to the 4. So we know that we've got 3 cubed here. And B is going to have another 3. For the 5, we've got 5 squared and 5 cubed, so there's 5 squared in both, and another 5 here. 7 and 7, so there's going to be a 7 in both, and an 11 here is going to be in here. So we've got B and A like that. Let's just finish that off. So A is 3 cubed, 5 squared, 7. That's correct. And then 3 to the 4, 5 cubed, 7 and 11 for B. So the highest common factor is 3 cubed times 5 squared times 7. So 27 times 25 times 7, 4725. And the lowest common multiple is everything multiplied together. So we've already done this bit here. So 4725 times 3 times 5 times 11. So take that and multiply it by 3, 5 and 11. 779, 625. Write that in standard form. So we've got 7.2 and then 1, 2, 3, 4, 5 decimal places like that. Work out this. 3 times 10 to the 6 is 3 million divided by 1.2 times 10 to the minus 3. So we're going to move that 1, 2, 3. So that's 2 zeros there. And we can just double check this on the calculator as well afterwards. So 3 million, 1, 2, 3, 4, 5, 6 divided by 0.0012 is 25, and then 1, 2, 3, 4, 5, 6, 7, 8. So 25, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 2.5 times 10 to the 9. Yeah. We can check that on the calculator. So we can put this in as 3 times 10 to the 6. And then divide that by 1.2 times 10 to the minus 3. And we get 25 and then the same number of zeros there. So that works out. Question 10, Henri buys a yacht for 200,000 euros. It depreciates by 15% each year. Work out the value after 4 years. So we're going to times that by 1 minus 15%, or 1 minus 0.15 is 0.85. And we raise that to the power of the number of years. So that will work this out for us straight away for compound interest. And that is to the nearest euro, 104,401 euros. The line in purple give the equation. So the equation should be in the form of y equals mx plus c, where m is the gradient. So let's just take a triangle here, and it goes across 1 and up 2. Just be careful of the scales. So change in y divided by change in x. So m equals 2 over 1. And the y-intercept here is equal to plus 1. So our equation is going to be y equals 2x plus 1. Calculate the length of AB. So we've got angles and sides, so we're going to be using trigonometry. We find the side that's in common to both, so in this case BD. So if we have that triangle here, then this is the opposite. We have the hypotenuse and we have the angle in there. So we're going to be using sine. Sine 30 equals O over 2.9. So O, the opposite is 2.9 sine 30. So you put that in your calculator. Sine 30 is actually half, so this is going to be 1.45. And we now know this, and we need to find AB. So our next triangle is going to be 1.45. We've got an angle of 44. And then we need to find this, which is the hypotenuse. So 1.45 is the adjacent because it's between the right angle and the angle. So cos 44 is equal to A over H. So the hypotenuse is 1.45 over cos 44. 1.45 divided by cos 44. That's 2.02 to 3 significant figures. 2.02 meters to 3 SF. Now there is another way that you could attack this question, is if you actually use sine rule on this, we can work out this angle in here, because this one is 60 from the first triangle and this is 44, so we'd have 104 in here, 30 here, 2.9 there, and we're trying to find out this side here. So we would need the opposite angle to this. So 104 plus 30, that leaves you 46 degrees in here. So let's just see if that works. Sine 46 over 2.9 is equal to sine 30 over AB, the one we're trying to find. So we can rearrange this to get 2.9 sine 30 over sine 46. 2.9 sine 30 divided by sine 46. 2.015. So we get the same answer if we use the sine rule directly without doing 2 steps of trigonometry. So, cumulative frequency, I just changed the numbers a bit here, and remember that we plot the end point of this. So we're going to do 40 and 2, then we're going to have 14, 45, 70 is 78, 92, and then 90 is 100, like that. So you would try and draw a smooth curve between these. That's not easy on here. So something like that, and we'd try and go through 0 there. Use your graph for the median. So the median would be going across at half of 100, that would be there. And that is coming down at 62. One of the adults is chosen at random. Use your graph to find an estimate for probability that they went for a walk for more than 72 minutes. So 72 would go up there. So that's 80, let's say that's 80, just over 80 there. 80, we could say 81 or 80 there. So as a probability, what we would have is we're saying that 81 people are less than 72, so we need to subtract that from 100 to get the number that's more than 72. So 100 minus 81 over 100 would give you 19 hundredths as a probability. So x to the 15 to the power of 3/5, we're going to do x to the 15 to the power of 3/5 multiplied by y to the 10 to the power of 3/5. 15 times 3/5 is 9, and then y, that's going to be 6. 10 times 3/5. We've got 3 to the n equals 3 to the x plus 1 over 27 to the y. So we're going to change the denominator into 3 cubed because we need them all to be the same power, the same base, sorry. So we've got 3 to the n is equal to 3 to the x plus 1, and then we're dividing by 3 to the 3y because we're multiplying those two powers. And then we're doing 3 to the x plus 1 divided by 3 to the 3y. So we're going to subtract these powers now. 3 to the n is 3 to the x plus 1 minus 3y. So an expression for n in terms of x and y, we can ignore the base now. N is x plus 1 minus 3y, or any version of that that is the same thing. Okay, different angle in here. We're looking at the arrowhead for the circle theorem, so that's going to be half of this, that's going to be 51. Give a reason, so angles at the point, angles at the center are double angles at the circumference. And then we have a diameter here, so that thing there is going to be a right angle. So angles at the diameter, angles at the circle circumference are going to be 90 degrees. So we can now work out 51 and 90. So 90 minus 51 is equal to 39 degrees in here. So DBC is that angle there that we've just worked out as 39. Okay, I've changed some of these numbers slightly. So find a formula for y in terms of x. Y is proportional, so inversely proportional to the square. So this is proportional to 1 over x squared. This is proportional to the, inversely proportional to the square of x, so it's proportional to 1 over the square of x. That's how that works. And then we change the proportional sign to equals k. Alright, so the proportional sign becomes equals k, and it's multiplied by 1 over x squared, so it becomes k over x squared. We can choose any of these to substitute in, so y is 5 when x is 2, so 2 squared, and we multiply by 2 squared and we get k equals 5 times 4 is 20. So our formula is y equals 20 over x squared. Given that x is positive, find the value of x when y equals 80. So 80 equals 20 over x squared. I can rearrange this by multiplying both sides by x squared and then dividing by 80. So I get x squared equals 20 over 80, which is a quarter. So x equals the square root of a quarter is a half, plus or minus a half. But it says that x is positive, so x will be equal to 1/2. I've changed the proof slightly. Proved that the sum of the squares of two consecutive even numbers are always divisible by 4. So if I have an even number, 2n, and I have the next consecutive even number will be 2n plus another 2, like that. Prove that the sum of the squares, so squares and the sum of them is going to be like that. I sum them together and I square them. So I get 4n squared here. This one, 2n plus 2 squared, like this. Don't forget, don't just square both of those. So we've got 4n squared plus 4n squared plus 4n plus 4n plus 4. You can see where this is going. 8n squared plus 8n plus 4. Now, to prove that something's divisible by 4, we just have to take 4 out as a factor. If it was divisible by 2, we take 2 out as a factor. If it's divisible by 3, we take 3 out. So we're going to take 4 out as a factor, and we get 2n squared plus 2n plus 1. So it doesn't matter what n is. We're going to square it, we're going to double it, we're going to add 2 lots of n, and we're going to add 1. But we're always going to multiply that number by 4. So when we get that answer at the end, we know that it will be divisible by 4, and we'll get a whole number here. 18 is a functions question, and we have a denominator with the x in there, so we cannot have a denominator that equals 0. So we just make sure that that denominator is equal to 0, and we solve that equation, and then x equals minus 4 over 3. So we're not allowed to have x equals minus 4 over 3, because if we do, when we substitute that in, we'll have to divide by 0. The only other thing that I've seen on this type of question for question 18 is if they have a square root sign and they have something under the square root. So let's say that was x plus 4. Okay, we can't take the square root of a negative number. So x plus 4 equals 0. So x equals negative 4. So if x is anything smaller than negative 4, like minus 5, minus 6, when we add 4 to it, we'll get a negative number under the square root sign. So that's the only 2 types of questions I've seen with those. Find fg of x. So with these composite functions, we take g of x, which is x minus 2, and we put it into f. So we're going to replace the x with x minus 2 for f. So we're replacing any x we see with x minus 2, and we're going to simplify this. So we've got 2x minus 4 over 3x minus 6 plus 4, which equals, well, actually we'll probably leave the top factored, so it's going to be 2x minus 2 over 3x minus 2. Question C, we're trying to find the inverse function of f. So we're going to let y equals, f was 2x over 3x plus 4. Then we replace the x's with y's in each case. So we're going to replace all of the x's with y's and vice versa. And then we rearrange this to make y the subject. So we're going to do x, lots of 3y plus 4. Multiply this out, equals 2y, and then collect these together. So 3xy minus 2y equals minus 4x. Factor the y, 3x minus 2, and then we divide. So y equals minus 4x over 3x minus 2. So once we've replaced the x and y's and then rearranged it, this is now our inverse function of f. Like that. You might also have, alternative to this would be 4x over 2 minus 3x if you rearrange these the other way around. So that would be an acceptable answer as well. When we put this function h of x on the grid, we want to find an estimate for the gradient when x equals negative 1. So x equals negative 1 is there. We can't tell what the gradient is, but we can draw a tangent at that point through there and work out the gradient of that tangent. So we could do a triangle maybe here and up and get an estimate for this, because this isn't exact here. We would use differentiation if we had the function, but we don't. So we've got 1, 2, 3, 4, 5, 6, 7, 0.7 along the bottom here, and then each of these is worth 1. So 1, 2, 3, 4, 5, 6, 7, 8.5 roughly. 8.5, 0.7 across the bottom. So the gradient would be the change in y, 8.5 divided by 0.7. 8.5 divided by 0.7 is approximately 12. So it's approximately equal to 12 for the gradient there. Now it seems like that's quite high, but that's because the scale on this is different. So 10 squares is just 1 along the bottom, and 10 squares is worth 10 up the side. So it's quite a steep gradient there. Okay, sector of a circle. So the formulas that we need are pi r squared times theta over 360 gives you the area of the sector, and then 2 pi r times theta over 360 gives you the length of the arc. Okay, so we're going to need to work out the arc length here, and also we need to work out this length here, because the perimeter of the shaded segment would be A to B and then APB. So we're given some information about the area of sector OAPB. The whole lot is 25 over 2. So 25 over 2 pi centimeters squared is equal to pi r squared times the angle 70 over 360. And we can now cancel the pi's and try and work out what the radius of this would be. So 25 over 2 times 360 over 70 would give me r squared. That's not going to be a nice number there. So we've got 25 over 2 times 360 over 70 is 450 over 7. So the square root of this, yeah, so r equals 15 root 14 over 7. So that's our radius. So we can add that to our information here. And we now need to work out the arc length. Now that we have the radius, we can work out the arc length APB. So 2 pi r times 70 over 360 will give us this part here. So I'm going to store the radius in the calculator, times by 2 pi, and then times by 70 over 360. That gives us a 9.795. 9.795 for the arc length. So we'll store that in B. I'm just going to write down that I've got that in there and that in A. So now we need to work out the length of AB. So we're going to need some trigonometry here. I've split this into 2 triangles. Let's call that M, and I've split this down the middle here. So we've got M, B, and then O. This is R for the radius. So the length of MB, which is the opposite, is going to be sine 35 is the opposite over R. So O equals R sine 35. So O equals the radius, which is A. So we're going to recall that. So we're going to do alpha A times sine 35. And that gives us 4.59. So O equals 4.59. And that is the length MB. So I'm going to multiply that by 2 to give me 9.19. And then add that to APB, which was B. So I'm going to add that to B in my memory. And that gives 18.99. So 3 significant figures. The perimeter is 2 times O there that we worked out, plus APB, and that gave us 19.0 to 3SF. So we've just got some smaller different values in here. So A is 2.52 to 3SF. So 3SF is 1, 2, 3, those 3 digits there. So I'm going to go plus or minus half of that accuracy. So up to 2.525 and down to 2.515. And then for 5.9 to 1 decimal place, so I can go 5.85 and up to 5.95. So if we want the lower bound of x, that means we need the smallest numerator and the largest denominator, so that when we divide this we get the smallest number. And if we want the largest denominator, that means we need, because we're subtracting two numbers, we want the largest b minus the smallest a. Okay, so the smallest denominator will be 6a, so the smallest lot of a that we can find, 2.515, and then we divide it by the largest b, 5.95, minus the smallest a, 2.515. Stick those in our calculator. The numerator is going to be 6 times 2.515, and then we've got 5.95 minus 2.515, and to 3SF that's 4.39. Question 21, we have two similar bottles and the surface area is in this kind of ratio of 80 to 180. So 80 for surface area of A to B, so 80 to 180, we can cancel that down, so we would get 8 to 18, and that's 4 to 9. So this is the surface area ratio. To make it a length ratio, we're going to square root this, so we get 2 to 3, and then the volume will be the cube of the length one. So we have to go to the length first and then to the volume. So that would be 8 to 27. Bottle B has a volume of 1215. So 1215, and we want the volume of this. So we're going to divide 1215 by 27. That's 45. And then multiply by 8 to get 360. So we times by 45 there, we divided by 45 there. If you want to use the ratio function on your calculator, then it has that one. We will be using number 1 here, 8 to 27. We don't know what x is, but we know that 1215 for the second one, and we get x equals 360. For question 22, we have a completing the square. We know that because it has this constant and then a bracket squared. So we have a negative 2 in front of the x squared, so we're going to take that out as a factor. So we get negative 2, and then we're going to do x squared minus 12x minus 3 over 2. So that when I multiply these out, I get negative 2x squared, negative 2 times negative 12 is positive 24, and minus 2 times minus 1.5 will give me positive 3. So I can complete the square now on this bracket. I divide the x term by 2, and then square it, and then I subtract 6 squared, and I've got my minus 3 over 2 still here. So this x minus 6 all squared minus 6 squared will multiply out to give x squared minus 12x. And then I tidy this up a bit, so I've got x minus 6 squared minus 36 minus 1.5 is minus 37.5. So now I can multiply out this and then this. and I get minus 2 brackets x minus 6 squared minus 37.5 times 2 is 75, is it? 37.5 times 2 minus 75. It's going to be positive 75 actually, minus 2 times minus that. So in this form where we've got the constant first, we would have 75, and then the number in front of the brackets would be minus 2x minus 6 squared. Okay, we've got a solid pyramid, and we need to find the angle between AC and the base BCDE. So AC and then the base, that means we need a triangle that goes to here, and that's the angle that we're trying to find. There's the right angle here. So the total surface area of 300 is made up of 4 triangles and the base. So the base area is going to be 8 times 8, and then we have 4 triangles where, if you take for example ABC, the area of that triangle would be a line from A to the midpoint of BC. So it would actually be a line coming through there. So that doesn't give us the length from A down to O, that actually gives us A to M. So the 4 triangles, 4 times half the base times the height, AM. Okay, so that length AM is actually the height of the triangle, if you like. So we've got 4 times half times 8 is 16 AM. Okay, let's just call that X. So the total area is 300, and that's equal to 64, which is the base, plus 16x. So 300 minus 64 is 16x. So x is equal to 300 minus 64 divided by 16, 14.75. So that is the length from A to M. Now we need A to O, so we need another triangle, A down to M, and then to O, and up here. So this is O here. And we've just worked out that AM is 14.75, and O to M, we can work that out here. O to M is half the distance from here to here, so that's just going to be 4, because it's just half the length going all the way across the middle, which we know is 8. So we can now work out AO by squaring the hypotenuse and subtracting the smallest side. So square that and minus 16 and square root this is not a nice number, 5 root 129 over 4. So that's the length AO. So store that in the memory. I'll put that in A. And we now have AO. We need OC, and then we can do trigonometry on this finally. So if I look at this sort of zoomed in version from M to O, this is C. Then M to O was 4, this is 4. We need OC, this is a right angle in here. So OC squared is equal to 4 squared plus 4 squared. So OC is square root of 32, which is 4 root 2. So we now have OC. There's O, C, and A. We know OA, which was 5 root 129 over 4, and OC is 4 root 2. We want this angle here, theta. We've got opposite and adjacent, so tan theta is equal to OA over OC. So OA, 5 root, yeah, that's that, and divided by OC, which is the square root of 32. And then I'm going to inverse tan that answer. 68.3 degrees to 3SF. Okay. A box contains marbles, 6 are red, the rest are yellow. Take a marble from the box and do not replace it. Then Sergio then takes one. The probability that they both take a yellow marble is 3/8. So let's just draw a probability tree and see if we can understand what's going on here. 6 of the marbles are red, the rest are yellow. So if we make x the total, then 6 are red, x minus 6 are the yellows. Okay, so if we go red, red, yellow, yellow, red, yellow, then the probability that both of them take a yellow marble, so we're going yellow, yellow, is 3/8. Probability of getting the first yellow is x minus 6, because that's the amount of yellows that we had initially, over the total. And then we subtract 1 from the second yellow. So it's x minus 7 over the total has also now reduced by 1. So that's the probability of picking the second yellow. And when we multiply these together, we get 3/8, because when you multiply down the branches, you get the probability at the end. So we're going to do x minus 6 over x times x minus 7 over x minus 1 is equal to 3/8. That's our initial quadratic that we're going to set up. We're going to multiply the numerators, multiply the denominators, like that, and then we're going to try and clear the fraction by multiplying both sides by x brackets x minus 1. So I'm just going to stick that up here and get rid of that, and then the 8 can go up here to clear that denominator. So we have 8 lots of x squared minus 7x minus 6x plus 42 is equal to 3x squared minus 3x when I multiply everything out. 8x squared, and then 8 times 13 is 104, so minus 104x plus 8 lots of 42, is that 336? 8 times 42, yeah, 336. Then we're going to minus 3x squared and add 3x so that I have an equals 0 quadratic. So tidy this up. 8x squared minus 3x squared is 5x squared, minus 104x plus 3x is minus 101x, and then plus 336 equals 0. So hopefully that will factorize. So 5 minus 101 and 336. So x equals 16 or 21 over 5. So x equals 16 or 21 over 5. You would have to use your quadratic formula that's in the front, plus or minus the square root, etc. And x equals 16, we would ignore this one because you can't have a fraction of a marble. So the total number of marbles that we have, we now know that x is 16, so 6 are red, 10 are yellow, because they add up to the 16 in total for x. Work out how many marbles are originally in the box, so that would be x16. Okay, so I hope that exercise was useful for you. When we change the numbers, we're still doing the same type of question, but it allows us to practice and see if we actually learn from our mistakes, as opposed to just trying to write them out when we get them wrong. So I hope that's been useful. Let me know in the comments below if you want me to do that for any other papers. Otherwise, good luck in your exams.